Okay, you guys, in this section, we're talking applications of rational equations. The goal is to solve work and constant motion applications. Okay, so here we go. First example, this would be the work application we're talking about. The San Paulo Community Swimming Pool can be filled in 12 hours if water enters through a pipe alone, or in 30 hours if water enters through a hose alone. If water is entering through both the pipe and the hose, how long will it take to fill the pool? So this is the kind of problem where it's hard to draw a picture. And when it's hard to draw a picture, I insist that you write some stuff down to help you understand the problem. Now it tells you, and this happens a lot in application problems, it tells you what the unknown is in the very last sentence. If the water is entering through both the pipe and the hose, how long will it take to fill the pool? So you could call it T or X. I'm just going to use X. What is X going to represent here? X equals time, right? But what kind of time units are we dealing with here? Hours. So X would be the number of hours, or just hours, it takes. Now, you know what? You can shorten it a lot if you want. I can shorten it even more because I know you guys don't like writing much. X equals hours, or number of hours, to fill the pool. Really, it's to finish the job, and the job is to fill the pool. Now, if what is true? It's the number of hours it takes to fill the pool if both the pipe and the hose are turned on. If both valves are opened. I'll just say it that way. If both valves open. Right? You know, a hose is going to have a valve, a pipe is going to have a valve, if both valves are open. Does that make sense? Okay, now we know the individual times. We know the individual times. So it's 12 hours. You don't have to write this down, but just to clarify, it's 12 hours for the pipe to finish the job. That's how long it takes, right? And 30 hours for the little hose to finish the job. 30 hours for the hose. What makes sense to do here? Does it make sense to take 30 plus 12? 42 hours, we're done. Now, why doesn't that make any sense at all? So if it only takes 12 hours for the pipe, is it going to take 42 hours if they're working together? If you have them both turned on? No, that doesn't make. So it should take less than the minimum amount of time for either the pipe or the hose, which is 12 hours for the pipe, right? It should take less than 12 hours. So common sense tells you it should take less than 12 hours to finish the job. The job is filling the pool. So it's not just an addition problem. In order to make it an addition problem, we have to find out how fast, per unit of time type of fast, the individuals are working, in this case, the pipe and the hose. And then we can make it an addition problem. So bear with me here while I write some of this down. So if it takes 12 hours for the pipe to finish the job, would you agree that the pipe fills 1/12 of the pool in 1 hour? Let me write that statement down. The pipe fills 1/12 of the pool per hour. I'll say in 1 hour, or you could say per hour. So that's the speed at which the pipe does the job, right? So using that same logic, what's the speed of the hose? The hose fills 1/30. Okay, you can use ditto marks. I know you guys don't like to write, so use ditto marks. The hose fills 1/30 of the pool in 1 hour. So now we've put both the speed of the pipe and the speed of the hose in the same units per hour, right? How much of the job gets done per hour. So now when you have things in the same units, can't you add them together? Yes. So before I do that, however, can you do the same thing with the x? If it takes x hours when they're working together, then what's the speed of filling the pool when they're working together? Using the same sort of logic. So if x were I don't know what it is, but say x is 10 hours. If x is 10 hours, you know, filling the pool, it takes 10 hours working together, both the pipe and the hose working together. It takes 10 hours to fill the pool. How much of the job would they get done in 1 hour? 1/10. If it takes x hours, how much of the job do they get done in 1 hour? 1 over x. So together, they fill 1 over x. That's the fraction of the pool that gets filled, or you can think of it as the fraction of the job that's finished in 1 hour. 1 over x of the pool in 1 hour. Now that everything's in terms of the same units, it should make sense that we can add the speeds together. So the pipe fills 1/12 of the pool in 1 hour. The hose fills 1/30. And shouldn't that equal the speed at which they fill the pool when they're working together, which is 1 over x? Does everybody see the equation coming out of this? Yeah? So you get 1/12 plus 1/30 equals 1 over x. Does that make sense to you? Let's solve this thing. How do we clear the fractions? What's the LCD here? Between 12, 30, and x. 60x. So remember, to solve these things, you're going to get rid of the denominators. When you're messing with an equation, you're not going to get a common denominator to add. No, you're going to get a common denominator to clear the denominators altogether. And you're going to multiply through by that common denominator of 60x. So multiply the left side by 60x, multiply the right side by 60x. Now on the left side, if I distribute the 60x, I'll go ahead and write it out here, 60x, 60x. So I distribute the 60x, I get 60x times a 12th plus 60x times 1/30. On the right side, by the way, that's easy. What's left? Just 60, right? Yeah. Okay. On the left side, okay, 12 goes into 60x. What's left? 5x. I thought you said 5. 5x. And then 30 goes into 60x. 30 goes into 60 twice, so plus 2x. 5x plus 2x is equal to 60. So now it's a reasonably easy equation to solve. What do? Okay, so 5x plus 2x is 7x. 7x equals 60, so x equals, yeah, divide both sides by 7. Okay, but wait a minute. This is one of those times where, okay, if you're just doing math, leave it as an improper fraction. But if you're trying to get an answer, I don't think an improper fraction is good. Maybe a decimal or a mixed numeral. So 7 goes into 60 how many times without going over? 8. That gives you 56, so what's left over? 8 and 4 sevenths, right? So just to remind you, 7 goes into 60 without going over 8 times. 7 times 8 is 50. Here's long division again. It keeps cropping up, right? Subtract, and you get a remainder of 4. So 8 and 4 sevenths. Now what are the units here? Hours. So could you summarize this if you had to? What would the summary be? Yeah, working together, the pipes finish filling the pool in 8 and 4 sevenths hours, right? So there you go.